Say we are given this fiber network with 6 nodes, 1 2 3 4 5 6, and written in red here, these are the transmission rates, and then here written in green, these are the distances between each node. So the question says, determine the approximate transmission rate B when communicating between N3 and N5. So that's basically the transmission rate between N3 and N5. In a question like this, we are going to focus on what we call a bottleneck. Focusing on the bottleneck. What am I writing? Bottleneck. But before you get your bottleneck, you need to trace the route from N3 to N5. So let's do that. The route from N3 to N5, here's N3, it goes to N4, N2, N6, and then it goes to N5. This is the route from N3 to N5. And then by bottleneck, I mean you need to find the lowest transmission rate along this route. And remember, our transmission rates in this case are written in red. So which is going to be, from here we have 14 and we have 9. 9 is lesser than 14, and then we have 9 and 70. 9 is lesser than 17. Then we have we still have 9 and 7. So in our case, 7 is our lowest transmission rate. That becomes our bottleneck. So to answer this question, our answer is going to be equal to 7 megabits per second. This is our answer for this question. Then the next question says, taking this approximate transmission rate into account, calculate how long in seconds will it take to transfer a 39 megabyte. Pay attention to this. 39 megabyte. This is MB. And remember, when we want to answer this kind of a question where when we're dealing with transmission rate, we always deal with megabits. So which means we have to convert this to this. And to convert megabyte to megabits, you multiply the megabyte by 8 all the time. So suppose we had, now we have 39. We have 39. So to convert it to megabits, we're going to multiply it by 8. And we're going to multiply it by 8. Let me try to turn on Math Solver. So 39 times 8, it's equal to 312. This is going to be our new value. Call it megabit. This is going to be our new value, the value that we're going to use, megabit, to calculate to answer the question. So say we were given 20 megabyte. So what you do, you convert this to megabits. It's going to be 20 times 8 is equal to, this is the value that you're going to use. But say here they said it will take 39. Say here they said it will take to transfer a 39 megabits like this. You do not convert it. So I hope that. So after converting, the next step that we are going to use is to, usually I try by all means all the time to simplify my life. So in cases like this, I have this triangle like where I write S stands for size, and then R stands for rate, and then T stands for time. So whenever the question says taking this approximate transmission rate into account, calculate how long in seconds, which means we are looking for time. So my formula is going to be S over R. T is equals to S over R. So T is equals to S over R. This is the time in second that we're looking for. So our S, this is the size, and the size that we had, it's this is the size that we have. Let me turn off MetSolver. This is our size, the one that we just converted or calculated. This is our size. It's going to be 312 megabit. Then R, this is our bottleneck. This is our bottleneck from 3 to n. So we have already calculated this from the previous question, which was 7 megabits. So it's going to be 7 megabits per second. Then you punch this on your calculator. Let me try to turn MetSolver and see what value it will give me. So 312 divided by 7, it's going to be, this is our, in seconds, this is the answer to this question. If you easily forget questions, if you easily forget the formulas, how to maneuver around here, try to practice this. I think this will help as well. Now let's move to another question. The next question says, if it is determined that the copper installed in this network propagates a signal at a speed of 270,000 kilometers per second, calculate the propagation delay for communications between N3 to N5. So we're still dealing with the same route, which is from here all the way until N5. So in this case, what you need to do is you need to add the distances. You need to add these distances, this from N3 until N5. So we had let me just write it here. Let me turn off my MetSolver. We're going to have 10 plus 20 plus 40 plus 80. Remember, it's from N3 to N5. Then the value that we're going to get here, it's going to be 150. This is our value. So, and this is 150 kilometers. So let's take this value and plug it here. Now we have the one that we have calculated. Let me just call it calc. It's fine. Well, it's 150 kilometers, and this is from N3 to N5. Remember, we are calculating determine if it is determined that the copper installed in this network propagates a signal at a speed of, calculate the propagation delay. Delay, this is time. Remember that formula that I just showed you, this formula. So in cases like this, I just like to tweak it a little bit since we're dealing with distances. Like to distance, speed, time. Our distance is the one that we just calculated, which is 150 kilometers. This is 150 kilometer. Then our time, this is what we're looking for. Our speed, they've given us the speed, which is 270,000 kilometers per second. So we are looking for time. Time, it's equal to distance divided by speed. So we're going to have the propagation delay. It is equal to distance of speed. Our distance is 150 kilometer divided by 270000. Turn my math solver. This is our propagation delay. No, actually, this is the value that we get from our. This is our propagation delay. This is our propagation delay. This in seconds. Pretty sure when you calculate it on your calculator, it's going to give you values like 0,005, something like that, 0,005516, like that. So yeah, just wrote it in scientific notation. Then we move to the next question. The next question says, if the line between N6 and N5 gets replaced with a faster line which is 10 Mbps, which is 10 megabits per second. What they're actually saying here is if they replace the bottleneck. That's what they're actually trying to say, replacing the bottleneck. Remember that our bottleneck is the one that determines how fast or slow we transmit, right? So remember, from N3 to N3, the bottleneck that we had was 7 Mbps, megabits per second. So we are going to replace that 7 with 10. Now let me try to redraw that. Let me do this. Copied. Let me try to bring this here and paste. We are replacing this 7 megabit by 10 megabits per second. Now our new value, our new bottleneck is, we have 14 and 9. 9 is our lowest, so 9 becomes our bottleneck. We compare 9 and 17. 9 still our bottleneck, and then 9 and 10. 9 is our bottleneck. So now our bottleneck becomes 9. It's no longer 7. Our bottleneck becomes 9 because we're still focusing on the same route from N3 to N5. So our bottleneck is 9 megabits per second. Remember, in the beginning we had 7 megabits per second as our bottleneck. Now we have 9 megabits per second as our bottleneck. Now we need to answer this question. This question says, if the line between N6 and N5 gets replaced with a faster line, will the transmission rate between N3 and N5 increase? Provide a reason for your answer. It does increase because now we have moved from 7 megabits per second. Now it increases. But if the value that let's say here we had 7 megabits per second. Let me just say we had 2 megabits per second, and we replace the 7 that we had here, and here we replace with 2. Our bottleneck would be 2 because now 2, it is the lowest on the route that we are currently using. I hope that makes sense and answers most of your questions in this type of question. Thank you. Please subscribe, and like.